So just like a repetition, is we saw that you have four major parts of the brain, and we say like this little stuff here. It is the one that is called the brainstem. It's made up of midbrain, pons, and medulla. So midbrain, pons, and medulla is what forms the brainstem. And then we said just behind the brainstem, we have this stuff here, which is known as the little brain or the cerebellum or the little brain. And just on top of the brainstem, on top of the midbrain, we said we have the diencephalon. This is diencephalon, which is made up of thalamus, AP, and hypothalamus. We have a separate video that we discuss about this diencephalon stuff, the thalamus and hypothalamus and the AP. The hypothalamus will be covered in the limbic system, and the rest will be discussed separately. And then just on top of the diencephalon is where we have the cerebrum, or the major part of the brain, which is the cerebrum. And today, now the focus of discussion today is the brainstem. So the brainstem, just like the name, is like the stem of the brain. Like we have the brain, we have the brain here, and then we have the stem. Just like how we had the stem of the tree, like this is the tree. So we have the stem that holds, or this, the higher part of the tree. So same applies to the brain, that we have we assume this is the brain, and then this is like connections, like a stalk of the brain. So it's like the stem of the brain. And we can see like this is the lower centers here is the spinal cord, and the higher centers of the brain is the brain. So it's like, just like I said, it's like a connection between the brain and the spinal cord. And in other words, like there is no way that information is gonna come from the spinal cord to the brain without passing through the brainstem. Without passing through the brainstem. We know that nowadays we're in a world full of wireless connection, but we are so primitive that we rely on wire connection between this central nervous system. So there is no way that information, because we don't have the wireless connection within the brain, so there's no way that information is going to come from the spinal cord to the brain without passing through the brainstem. Because we don't have we don't have wireless connection. So that's one among the obvious function of the brainstem, is to conduct information between the spinal cord and the brain. But is that the only function of the brainstem? No, excuse your brainstem, not, because the brainstem is not simply a channel that that communicates between the brain and the spinal cord, because it has got the nucleus of its own. It has a lot of nuclei that will help in performing different functions. Just to mention a few, the brainstem has got control the cranial nerves. So the cranial nerves are being controlled by the brainstem. At least the 10 lower cranial nerves. We discuss about them. But the level of consciousness, I am conscious now, like talking to you because of the brainstem. And respiratory functioning, cardiac functioning, and cerebellar circuitry, communication between the cerebellum, as we can see, is just behind the brainstem. There's no way that this is communicated with the brain, with the cerebrum, without using the brainstem. But muscle tone and posture, these are just few functions of the brainstem. We have, maybe we have a separate video talking about this brainstem function. So this is to say, like, in summary, the brainstem is unsung hero of the brain. It's unsung hero of the brain. Why? Because it does all of this vital functioning, like cardiac and respiratory. These are in my opinion, these are the most exhausting system in the human body. These are the most exhausting system. Why? Because the cardiac functioning, the cardiac and respiratory, they 24/7 stuff. Right? You have to do it from. Since you are born till today, you haven't. Your cardiac system hasn't rested yet, even your respiratory system. So every time, every single minute, every single second, they are on work. And guess what? The the cerebrum now at times it takes nap, it takes nap, it goes to sleep at times, because not all the time your cerebrum is at work. But guess what, the brainstem here is always on work. Because why? Because it has to control the respiratory function and cardiac function, which are the most exhausting systems in the human body. Because every single minute they have to be on work. Even if I'm asleep, I still want to like breathe in, breathe out, and having this heartbeat. So he's unsung hero of the brain, unsung hero of the brain. He does all the work, but the credits go to the cerebrum. Yeah, it happens even in our daily life. Like sometimes you do a lot of work and the credits go to somewhere else. Especially in the politics. I don't want to talk about politics. So we can see like all of these functioning are compacted in this little stuff here. So just a small region in the brainstem can lead to substantial deficit. A small region in the brainstem can lead to substantial deficit. Why? Because we've seen it does all of these vital functioning. And then let's see the orientation or adjacent structures to the spinal to the brainstem. So this is the brainstem, as I've said. It is made up of midbrain, pons, and medulla. Midbrain, pons, and medulla. And mind you that the thalamus is not the part of the brainstem. The thalamus, it is not the part of the brainstem. It is the structure of the soul, and it's found in the encephalon. So the brainstem starts at the level of junction between thalamus and the midbrain, or it's called, because midbrain comes from the mesencephaly, so it is called the mesencephalic diencephalon junction. And then it ends at the level of the foramen magnum, where the medulla becomes the spinal cord after it's goes through the foramen magnum. So the upper junction here is known as I've said, the midbrain diencephalic junction, or the mesencephalic diencephalic junction, and the lower one here is known as the cervical medullary junction. Why? Because it's a junction between the cervical part of the cervical part of the spinal cord, the cervical spinal cord, and the medulla, which is medullary now. So it's a cervical medullary junction because the junction between the cervical part of the spinal cord and medulla. So these are the major limits, the proximal and the distal limit of the brainstem. Now we have because we have midbrain, pons, and medulla, we can also have the junction between midbrain and pons. We can have junction between pons and medulla. So the junction between midbrain and the midbrain and pons, it is known as ponto-mesencephalic junction. Ponto-mesencephalic junction. Because ponto for pons, mesencephalic for midbrain. Remember, it originates from the mesencephalon. And yeah, so that's the junction between pons and medulla, and pons and midbrain. And now the junction between pons and medulla is known as pontomedullary junction. So these are the literary junction that will help us to separate between the two, between the brainstem. And just to mention, the brainstem lies in the posterior cranial fossa. Probably you can't see this, but we discussed about the the cranial fossa, anterior, posterior, and middle cranial fossa. So these are the different orientation, different views of the brainstem. This is a ventral view, and this is posterior view or the dorsal view, and this is the lateral view of the brainstem. So just to mention, I mean, we want just to see the major parts of the brain stem. So we have this is known as the midbrain. So this is the midbrain, and here is a midbrain. Eh? So this is the pons. Here is a pons. I mean, you can excuse my lines were not perfect. It had to pass through here. So all this is the pons, and all of this is the pons. All this is the pons. Eh? And then same applies here in the medulla here, medulla, or the so-called medulla oblongata here, and here is medulla, and then the lower part here is the spinal cord. So this is the spinal cord, and spinal cord. Remember, I told you that the thalamus is not, this in red here is not the part of the brainstem. It is not the part of the brainstem. So now let's discuss about the surface anatomy of the brainstem in details. Yeah, so let's touch on the midbrain and the posterior aspect of the midbrain. So here is how it looks like on the posterior part of the midbrain. So the posterior part of the midbrain is also known as the tectum. Tectum means a roof, a roof. So it is made up of, I mean, it has like bumps or elevations. It has the elevations, the four elevations. We call them four elevations of four bodies. Two which are superior, and two are inferior, and we call them colliculi. So we have superior colliculi. So in singular is colliculus, but in plural is colliculi. So we have superior colliculi, left and right, superior colliculi, and then we have inferior colliculi as well. So left, right, and left. So they are also inferior colliculi, but because they have labeled only one, so we call it colliculus. But if in plural, we call them colliculi. So all these four structures, they form four structures which we call them four rounded bodies or four structures. Now we want to translate it into, into Latin. It's when we say, now we call them corpora quadrigemina. So corpora quadrigemina is another term that refers to all these structures together. So superior colliculi and inferior colliculi are together called corpora quadrigemina. Corpora quadrigemina, or the four bodies. Now the superior colliculus, it helps in visual activities. We have a separate discussion that we discuss about the visual, spatial attention, eye movements, and accommodation reflex and head reflexes, head movement. That's a separate thing. I wouldn't like to incorporate in this video, but we have a separate session. But I mean, at the moment, you can just memorize that the superior colliculus help us in movement, in visual activities. One among it is visual spatial attention, or the visual attention, and some movements of the eyes. But you just, at the moment, until we discuss about all these stuff, you can tell us. But for today, you just memorize that it helps in visual activities. And on the other end now, on the inferior colliculus, so the inferior colliculi will help on auditory functioning. Also we have a separate video discussing about that, but you just remember, superior colliculus is for your eyes, and inferior colliculus is for your ears, for your hearing. You discuss them in details. But one among the most exciting, most fascinating function of the inferior colliculus is a startle reflex, or the motor reflex. The startle reflex or the motor reflex. This is that reaction that you get when when a sudden impulse is applied. For example, when you hear a very large, a very loud noise or something, like when you hear loud noise or something, you react to that impulse, like you, yeah, that's a startle reflex. But also when someone makes how can I make it? How can I make it this? But that sudden any kind of sudden impulse can make you like react, and that reaction is what we call it the moral reflex. I mean, I have a video here. You just watch it and see. Fascinating. So that's like a laugh-free moral reflex. The cat is responding to the impulse that, I mean, to the sound that is coming from the alarm or from the clock. And in we have some reflexes in newborns, and we also have this moral reflex in newborns, which is uh, which is which is a sudden reaction to it's a reaction of the sudden movement. For example, when you take like newborns baby and then you make a sudden movement like this. Let's watch this video and then we discuss it. You see, the examiner or the physician here made a sudden movement of the body, like sudden dropping of the baby, and the baby reacted by stretching the arms and stuff. So that's a reaction towards the sudden movement that was made by the examiner. So that is to say, so that's the moral reflex. I mean, we'll have a separate video discussing about the reflex, but you know that it's a part of it is executed by the inferior colliculi. So other structure that can be seen on the posterior surface of the brain, of the midbrain. Midbrain, we have these two like elevation or something that communicates with. So we have this we call the lateral geniculate body, which communicates with the superior colliculus. So the lateral geniculate body is not the part of the brainstem, it's not the part of the midbrain. I mean, it is part of the encephalon, but it communicates with superior colliculus. So whatever the superior colliculus does, the lateral geniculate body helps in too. So it's also it's important in visual activities because it does almost the same. And then we have the one here, another one here, which is known as the medial geniculate body. So the medial geniculate body communicates with the inferior colliculus, as you can see, like it communicates with the inferior colliculus. So it's also important in auditory functioning. So the superior colliculus, the lateral geniculate communicates with the superior colliculus, and the medial geniculate communicates with the inferior colliculus. And then we have another thing here, which is known as the pineal gland. So the pineal gland, or epiphysis cerebri, it is an internal clock. It is an internal clock, which is controls the circadian cycle. So you go to sleep over the night, you are waking in the morning, is because of this gland, the pineal gland. Is what controls your sleep cycle, which is known as circadian cycle. And we also have another video, a separate video that discuss about the circadian cycle. And so we have a nerve that originates on the posterior aspect of the brainstem, of the midbrain, which is known as the trochlear nerve. The trochlear nerve is the only cranial nerve that exits the brainstem on the posterior surface. All other cranial nerves will either exit from the ventral side or the ventrolateral side of the brainstem, but only this trochlear nerve comes on the posterior surface, comes from the posterior surface of the brain stem. So that is it about the posterior aspect of the midbrain. We're discussing now about the midbrain. So let's stay on the ventral side, on the anterior surface of the midbrain. So this is how it looks like on the anterior surface of the midbrain and we have two peduncles here, cerebral peduncles. So cerebral peduncles, one on the right side and the other one on the left side. So they are, I mean, we see on the internal anatomy how these cerebral peduncles are made, but they are just they have some nuclei and fibers that they are tracks that communicate between the key information between the higher centers of the brain, the spinal cord, and the lower centers. We see when we discuss about them. But we have a nerve that originates on the ventral surface of the midbrain. So not something that from the midbrain we only have two nerves that originate from the midbrain. We have this trochlear nerve. We have the trochlear nerve. We on posterior side we have the trochlear nerve, and now we have the oculomotor nerve, cranial nerve number 3. So cranial nerve number 3 and the cranial nerve number 4 are the only nerves that takes origin from the midbrain. Only nerves that take origin from the midbrain. So the first two cranial nerves, cranial nerve number 1, number 2, they don't originate from the brainstem. They originate from the higher centers, but the cranial nerve number 3 and number 4, they originate from the midbrain. The rest of the cranial nerves, they originate on the lower parts of the midbrain, which is Pons and Medulla. So only true cranial nerves from the midbrain. On the ventral surface is the oculomotor nerve, cranial nerve number 3, and on the posterior surface or the posterior aspect is the trochlear nerve, which is cranial nerve number 4. Yeah, and then we have some other stuff that we can see here on the ventral aspect of the midbrain. We have this optic nerve, optic chiasm, and optic tracts. Do not worry about this at this moment because we have the separate video we discuss about the visual pathway. So don't memorize. I mean, don't use much energy to memorize this stuff. So we have a separate video, and we also have a mammillary bodies around here, so we call it mammillary body, and it's also a part of the diencephalon. All of these reddish stuff, they are not from the brainstem, so they have another origin. And for this case, this mammillary body is coming from the encephalon. So it helps in the limbic system, and the primary function of this mammillary body is corrective memory. Corrective memory. So that's it from the midbrain, the surface anatomy of the midbrain. So let us move to the pons. Let us move to the pons. So this is the pons, and just like the name, the pons the word pons means the bridge. So it is a bridge, but as we have said, it's not a simple bridge because it has got some nuclei of its own that that means it can control some other functions. So the pons is just a 2.5 centimeter long, 2.5 centimeters. So it's very short, and as I've said, it has got some nuclei. It's not a simple bridge. So let's discuss about the surface anatomy of the pons. So on the ventral aspect of the pons, we have some groove or sulcus, which is known as basilar groove or basilar sulcus. And this basilar groove is where the basilar artery will pass. So this impression is made by the basilar artery. So the basilar artery rise on this surface of the brainstem of the pons to form this basilar groove. I mean, there's not much on the surface of the brainstem or the surface of the pons. So not much surface anatomy there is not much to discuss. So let's see the nerves that originate from the pons. So we have this trigeminal nerve, which is cranial nerve number 5, the trigeminal nerve, which originates from the pons. We also have some other nerves like the abductor nerve, which is cranial nerve number 6, cranial nerve number 7, and number 8, vestibulocochlear nerve and facial nerve. So but we can say, you can see here, like the trigeminal nerve is like the only nerve that will come from the pons proper, I mean the pons per se, we can say. All of these three nerves here, they come from the pontomedullary junction, the junction between pons and medulla. Pons and medulla, so the pontomedullary junction, we can see. So all these three cranial nerves, cranial number 6, number 7, number 8, they come from the pontomedullary junction. But we can say now, if someone asks you about all of these nerves, the pons, I mean the cranial nerve number 5 and through number 8, they are associated with pons, but the only one that comes from the pons proper is the trigeminal nerve. The rest three, they come from pontomedullary junction, the pontomedullary junction. So that is it from the anterior surface of the pons. Let's take a look on the posterior aspect of the pons. So on the posterior aspect of the pons, you know, the pons is like it usually connects with the cerebellum. So here the cerebellum is cut. We cannot see the cerebellum, but we can see the appendages of the cerebellum that we call the cerebellar peduncles. And remember, we've discussed this cerebellar peduncle while discussing the cerebellum. So we, just as a repetition, we have the superior, middle, and inferior cerebellar peduncles. They also communicate. They help communication with the cerebellum. And now we have two elevations here. We call them the fascial colliculi, or simply one would be the fascial colliculus. And this fascial colliculus, we see that we see when we discuss in the internal anatomy of the brainstem. But it's just the fascial nerve loops around the abducens nucleus. So the fascial nerve, the fascial nucleus, the fascial nerve loops around the nucleus for the cranial nerve number 6, which is abducen nerve. And then lastly, let's discuss about the medulla, so as the last part of the brainstem. So the medulla is also known as the medulla oblongata, or simply you can call it medulla. It's a lower portion. It's a lower the caudal portion of the brainstem, and it is in continuation with the spinal cord. So as soon as you go through the foramen magnum, this is the level of foramen magnum, the cervicomedullary junction, the medulla changes into spinal cord. It changes to spinal cord. It is like 3 centimeter long, and 3 centimeter is just a short distance. So it's a 3 centimeter long, and it has got as we've said, it begins at the level of the foramen magnum. So that's where it changes name from the medulla to spinal cord, or from the spinal cord to medulla when you reach the level of foramen magnum. So what among the most distinguishing features of the brainstem, of the medulla, is the pyramid. So we have the pyramid here, and the pyramid is just accumulation of white matter bundles. So they attract the motor tracts specifically that take information from the brain to the lower parts, to the spinal cord. And we have some crossing over of information here at just above the cervicomedullary junction, just above the foramen magnum, and we call it the pyramidal decussation. The pyramidal decussation. So the pyramidal decussation is a crossing of fibers through the pyramid, within the pyramids. So from left pyramid to right pyramid, and from right pyramid to left pyramid. We discuss about this as we're moving in later videos, but it's just a simple crossing of fibers. But I always ask students what is clinical significance of pyramidal decussation. Well, pyramidal decussation is the one that determines the contralaterality of the brain. I mean, most of this of the motor fibers of the motor areas of the brain as we've said, like if someone has got damage on the left side of the brain, so the motor deficit will be on the right side of the body. And if someone has got injury or lesion on the right side of the brain, and the motor deficit will be seen on the, I mean, all the deficit will be seen on the left side. But what determines the motor deficit on the other side of the body, or the contralateral side, is the pyramidal decussation. We discuss about it sometimes later. Another distinguishing feature of the medulla is the so-called olive, inferior olive. So the inferior olive, it takes part in the inferior olivary system, where it is involved in timing, learning of motor skills as well as coordination. It's also a distinguishing feature of the medulla. Now let's see the cranial nerves that originate from the medulla. We've already seen the cranial nerve number 3, number 4, number 5, number 6, number 7, and number 8. And now we have remained with cranial nerve number 9, 10, 11, and 12. So 4 of the cranial nerves originate. 4 cranial nerves of the 12, they originate from the medulla. From the medulla, So from the medulla. So from cranial nerve number 9. So the cranial nerve number 9 here, which is known as glossopharyngeal on the ventral side, and on the lateral side, it is the very first nerve to come from the medulla. And then we have the vagus nerve here. So this is the vagus nerve, and this is the vagus nerve, and this is also a vagus nerve. So it's also vagus nerve. And then we have spinal accessory nerve, cranial nerve number 11 here. It originates here. So we know that the cranial nerve number 11 has got like double region. It has a region from the brain, or it has the cranial part, which originates from the medulla, and it has also got the spinal contribution. So we have contribution from the spinal cord. As you can see, this is the spinal accessory nerve, and here is the level foramen magnum, which means here is the spinal cord, and here is the medulla. So we have some contributions from the spinal cord, and other contribution from the medulla. So it has got the cranial part, or cranial contribution, and the spinal contribution. And lastly, we have another nerve here, which is known as the hypoglossal nerve, or cranial nerve number 12. So the cranial nerve number 12, you can see here, like it originates between the pyramids and olive. So we have, this is olive, inferior olive, and then this is pyramid. It comes in between. So it originates in between the pyramids and olive. So it's also known as pre-olivary sulcus. The pre-olivary sulcus, because it's just before you go through the olive is when you find this nerve. So it originates from the pre-olivary sulcus, and it is just between the pyramid and olive. And then down on the dorsal surface of that was the ventral surface. That was the ventral view of the medulla. On the dorsal surface of the medulla, we can see on the dorsal surface, we can see we've already seen these nerves that originate from the medulla. Now we have some elevations here. We got this one, for example, is known as hypoglossal tone. Trigon, the hypoglossal trigon, which is it marks the nucleus for the hypoglossal nerve. And then this one here, is vagal or vagal trigon, which marks also the nucleus, the dorsal motor nucleus of the cranial nerve number 10, which is a vagus nerve. And then we have something here is known as obex. So the obex is it marks the lowest point at which the cerebral spinal fluid leaves the ventricular system to enter the spinal cord canal, the spinal cord central canal. So, for example, here is a central canal. This is so this is the first ventricle, and then here is the central canal. So as we are moving through the central canal, as we are entering the central canal is where we find the orbix. So here is the orbix. So here is the orbix. I mean, I was looking for the, yes, this arrow. So here is the orbix of the orbix, which marks the entry point to the central canal of the spinal cord, and here is the foramen of Magendie. So my point was, as you are moving from the ventricular system of the brain, like the fourth ventricle, now this cerebrospinal fluid has to leave the ventricular system, so it will go through the median aperture and lateral apertures, median aperture of Magendie, the lateral apertures of Rushika, and then it has to go through the central canal of the spinal cord. How does it go there? It goes through the orbix. So the orbix acts as the opening. So we discuss about this ventricular system sometimes later, but I want you to notice that the orbix is not the same as foramen Magendie. And you know what? Students are so funny, because now I'm telling them that orbix is not the same as the foramen Magendie, but in exam this is what they will exactly write. So they will write either this is orbix structure, for example structure J is orbix or foramen of Magendie, anaweka kwenye mabano. So that's wrong. It is not the same. And then we also have the nucleus gracilis, nucleus cuneatus, and nucleus gracilis, which they are continuation of fasciculus gracilis and fasciculus cuneatus, respectively. So now, the spinal cord resembles the medulla in a number of ways. So these two structures are almost, sometimes difficult to differentiate. But we have some few features that will help us to differentiate between medulla and spinal cord and medulla and spinal cord. So number one, the most key external features that you can use to differentiate spinal cord from medulla from spinal cord. Number one is pyramid, and number two is inferior olivary nucleus. The pyramid is not seen on the spinal cord, so the pyramid is limited to the medulla, and it's not seen on the spinal cord. Number one. Number two is inferior olive. So the inferior olive is also limited to medulla, but it's not found throughout the medulla, meaning it is limited to the proximal portion of the medulla, or the rostral end of the medulla. On the caudal end, it's not very much appreciated, but it's still limited to the medulla, so it's not seen on the spinal cord. So these two are the most distinctive features on the external features of the medulla, as you differentiate medulla and the spinal cord. But we on the internal anatomy, we see that the orientation of white matter is also different between the medulla and spinal cord. Just to mention a few, is in the medulla, because it's a brain, the gray matter is on outer side, and the white matter is found inside. So the gray matter outside, the white matter inside. We'll see why we discuss why we are taking to discuss the internal anatomy. And other features now that other differences that can be used is like a shape of the shape of the two. The spinal cord is almost cylindrical. It's like a cylinder in shape, it's just a cylinder in shape, as you can see. But the medulla here is a conical in shape. As you can see, it becomes to be a cone, so it's like inverted cone. So it's conical in shape. And another thing is these nucleus, gracilis, the tubercles for gracilis and the tubercle for cuneatus. They are wider on the medulla as you compare to these fasciculus gracilis and fasciculus cuneatus. But I tell you what, if someone asks you in exam to mention the differences, you either use these two, either these two. So the the pyramids and orifice and the orientation of white and gray matter. But you also have to pay attention to the question, because sometimes someone can be specific, like he or she wants you to mention the external features. So if the external features will not mention about the orientation of white matter and gray matter, because that's the internal surface in internal anatomy of the of these structures. But if someone is specific about the internal, you mention the orientation of white and gray matter. But if someone is also specific on external features, you have to mention pyramids and horns. I guess that was it about the surface anatomy of the brainstem. And let us take a look briefly on some questions that can emerge from that can arise from the brainstem anatomy, surface anatomy. I mean, we have a lot of questions that can emerge from here, but let us take take a look at some of the questions. So the first question is, which of the following cranial nerves emerges between the pyramid and orifice on the ventral surface of the medulla? Which of the following cranial nerve emerges between the pyramid and orifice of on the ventral surface of the medulla? So A is glossopharyngeal nerve, B is vagus, C is hypoglossal nerve, D is facial nerve, and E is accessory nerve or spinal accessory nerve. So make sure you write your answers in the comment. Write the answer in the comment. And another question is, so this is like a form of a sport type of question that's gonna come some at points in your exam, in your practical exam. So the question says, identify the structure I and J. So identify the structures I and J. And the second question is, what is the clinical significance of structure J? You can see how simple this question is, but you find always students, because they haven't at some point, or due to some reason, they haven't passed through the videos, or they haven't read some books, and they think it's some form of rocket science or something. But no, this is not. So that marks the end of our tour on the surface of the brainstem. Now you can confidently tell the midbrain from medulla, spot those key landmarks, and even start connecting them to their clinical significance. So so next time you see the brainstem, don't just glance, read it like a map. So thanks for watching, and if this video helped you to clarify things, drop a comment below and share it with your friend who is still mixing up the orifice and pyramids. And hey, we still have a lot to discuss on the brainstem, so if you haven't subscribed yet, make sure you subscribe and hit the bell icon for you to get a for you to get the notification on the new video as soon as it is made public. So stay tuned until next time. Thank you for watching.